Hey guys, in this video we're going to take a look at our first bit of trigonometry inside of 3D shapes. So if you haven't already checked out my video on 3D Pythagoras, do check that out first because we're using exactly the same mindset as we do in that video. Now really there is no such thing as 3D trigonometry or 3D Pythagoras. We can use trigonometry and Pythagoras inside of 3D shapes on 2D shapes that are hidden inside of them. So let's get cracking with a bit of trigonometry. Now in this question we're going to be looking at a cuboid A, B, C, D, E, F, G, H, and we're going to be wanting to find an angle. Now in this one we're going to be looking at finding angle AGE. So let's first of all figure out where that angle is. So the angle AGE is the angle formed when we go from point A down to point G and then across to point E. So we're looking for this angle here. Let's call it theta. Now at the moment that looks quite messy on the next page. I've cleaned everything up. But let's just talk about what we've got here. Well, we know that this is going to be a right angled triangle AGE. We know it's right angle because we're dealing with a cuboid, so the angle down at point E is going to be our right angle. So let's just label this triangle that I've drawn here. That's point A, this is point G, and this is point E. And this is the angle theta that we're trying to find. What else do we know about this triangle? Well, we know that the height of it is 12 centimeters. So we know that when we're playing SOHCAHTOA inside of right angled triangles, if we know two side lengths, then we can use them to find either of the two missing angles. So if we could either find side length AG or side length EG, we'll be absolutely golden. We will be able to find the angle. So what else do we have inside of this cuboid? Well, we actually have another right angled triangle going on the base of the cuboid. The line EG is actually the hypotenuse of another triangle, and that triangle is going to be EGH. So this triangle here on the bottom of the cuboid. So here we know the point at H is a right angle, and we also know two lengths of this triangle, which is really useful to us. So we know that the length EH is 3 centimeters, and we know that the height GH is 4 centimeters. Now, what famous theorem can we use inside of right angled triangles when we know two lengths to find another length? We can play Pythagoras. So, let me just point something out here. This line, the hypotenuse, EG, on the bottom triangle, the hypotenuse of that is the bottom length of our big triangle, EG, as well. So if we can use Pythagoras to find that length, we then know the second length in our first bigger triangle, then we will know two lengths in that first triangle, and we'll be able to play trigonometry. So let's tidy things up a little bit and have a go at doing just that. Okay, so on this page I've redrawn the triangles a little bit neater and tried to use colour again to show hopefully what's going on a little bit clearer. So if we look in the cuboid, we've got the big tall right angled triangle who has the black height, the red base going along the bottom of the cuboid, and then the blue hypotenuse. And then we also have the smaller right angled triangle whose hypotenuse is the red length along the diagonal of the base, and then the two sides are the bottom lengths of the base of the cuboid. So again, what we're going to do then, we're going to use Pythagoras in the triangle on the base because we know two of its side lengths, which is all we need to be able to play Pythagoras. And then we're going to use Pythagoras to work out the length of the red line, which will then give us the base of our big tool triangle, and then we'll have two sides, and then we've got all that we need to play soccer tower. Okay, so let's do the Pythagoras then. Let's call the base of this triangle A, and then the height of it B. Now remember, Pythagoras tells us a squared plus b squared equals c squared. So here, 3 squared plus 4 squared equals c squared. Now we know 3 squared is 9, 4 squared is 16. So add those together, we get 25 is equal to c squared. Then if we square root both sides, we will get c is equal to 5 centimeters. So now we know the length of the red hypotenuse here is 5 centimeters, which also makes the base of the big tall triangle 5 centimeters because they are the same length. Cool. So now we are done with the bottom triangle, and we just now need to play inside of the big tall triangle. So we now know two of the side lengths. We've got the height, 12 centimeters, and the base length of 5. So now we can just play soccer tower. So let's label the triangle in terms of trigonometry. So if we're dealing with angle theta, the 12 centimeter height is the opposite, and the 5 centimeter base is the adjacent. So now we go to soccer tower and ask, right, which of our three functions do we use? Do we use SO, S-O-H, no, CA, C-A-H, no, tower, T-O-A, yes indeedy. So we are dealing with then tan. Now the tan identity, remember, it tells us tan of theta equals the opposite divided by the adjacent. If we plonk our numbers in, we get tan theta is equal to 12 fifths. And then remember, as our final step, to get an angle out of a trig function, you take the inverse function of both sides. So we take the inverse tan function of 12 over 5. So I'm going to go down to the bottom left now because I've run out of room. So we get theta is equal to the inverse tan of 12 over 5. And if you stick that into your calculator, you will get theta is equal to 67.4 degrees to 1 decimal place. Okay guys, that's our first taste of trig in 3D shapes. Hope it's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.